Alright, so we're going to continue on building off of what we did yesterday, so let's do a quick review of the things we looked at yesterday. Inverse sign. What were some of the things we needed to know about inverse sign? Domain is -1 to 1, the range is -pi/2 to pi/2. Alright. Always. Inverse sign is always that domain and range. Yes. We needed to have the graph of it. So, the graph of inverse sine, what were the x values on my graph? -1 to 1, and the y values were -pi/2 and pi/2. Okay, and remind me what this curve looked like over here. Was it like this?
Yes.
So I got a curve here, and I have the curve there. So that's the graph of inverse sine. Okay, what are we going to use the graph of inverse sine to help us find?
Quadrant.
If I don't have a match on my special angles, that means it's got to be a quadrantal. So that means it has to happen. It has to happen at one of those 3 points. Okay. Now, what else did we use the graph to help us figure out? Say it again. Okay, here's what the other part was. You guys with me over here? The other part was if I had a negative number inside of an inverse trig function, we needed to know how to handle that negative number. So how do we handle negative numbers if we're dealing with an inverse sign?
It's just making
We just make it negative. And we knew that because of the graph, because on this side, all of my numbers are negative, and notice that corresponds to this piece of the graph, and all my y values are negative. So every x value that's negative on the inverse sign produces a y value that's negative on an inverse sign. Okay? So that's what we need to know from inverse sign. Domain and range from inverse cosine. What's the domain of inverse cosine? -1 to 1. And the range?
0 to pi.
0 to pi. So the graph of this one, we're still going -1 to 1 here, but we're going from 0 to pi. Okay, and this one looks like that, correct?
Yep.
Okay, so again, we get the quadrantals, which is going to be here, here, and here. And then we figured out that if we have x values that are negative, that corresponds to this piece of graph, which corresponds to these y values, and those y values have to be between pi/2 and pi. So if I have a negative number inside of an inverse cosine, what did we do to our answer?
the numerator is 1 less than
The numerator of our answer needs to be 1 less than the denominator. Exactly. Okay? So that's what we looked at yesterday. So today we want to hit inverse tangent. We want to hit inverse tangent, and then we want to look at some composite functions that deal with regular trig functions and inverse trig functions. That's what we're looking at today. So to look at inverse tangent, what do you think we want to look at first? The original graph of tangent. That is correct. And again, you don't have to write this down until I tell you to write it down. So inverse tangent, if you remember, splits. It's going to go up this direction. It's going to go down this direction. This is -pi/2, and this is pi/2. And again, this will continue on. I've got another one here. Goes up there, goes down there, and it continues on. So if I put all of it together, what does it fail? What test does it fail? It fails the horizontal line test. So that means I need to do what to it? I need to restrict it. So I need to figure out some x values to restrict it. And tangent's a little bit easier to see than sine and cosine. It should be obvious what I need to do to restrict it. And what should I restrict it to? -pi/2 to pi/2 is what I want to do. So -pi/2 to pi/2 is what I want to restrict it to. Okay, this piece of the graph right here hits all of my y values and it passes the horizontal line test. Okay, so the domain of tangent I want to be what? Negative pi over 2 to pi over 2. Now, if you remember, isn't that the domain of sine or the domain of sine that I used? But there's one slight difference between the domain of sine and the domain of this tangent. What's the slight difference?
And sine's the range.
They're the same thing, but there's one little difference. What's different about the tangent graph and the sine graph? Alright. Asymptotes. Tangent has asymptotes. So what does that mean I have to put on negative pi over 2 and pi over 2? I have to put parentheses. That's the small difference between the domain of tangent and the domain of invert or domain of sine. Okay? Alright, what about the range of this? What's my range of this little piece? Negative infinity to infinity. That is correct. Alright, so now we're ready to go to inverse tangent. This is what you want to write down. So, what does that mean the domain of inverse tangent needs to be? Negative infinity to infinity. And what does that mean the range needs to be? Negative pi over 2 to pi over 2. Alright, what else do we want to do besides get the domain and range for inverse tangent? We want to graph inverse tangent. So what x values will I use for inverse tangent? Negative infinity to infinity. What y values will I use? Negative pi over 2 to pi over 2. Okay, over here, what is on negative pi over 2 to pi over 2? Asymptotes. So what needs to be on my inverse at pi over 2 and negative pi over 2? Asymptotes. Except what type of asymptotes will I have this time? I'll have horizontal. So I've got a horizontal asymptote there. I've got a horizontal asymptote there. Okay? So then we want to look at some points. This point right here is 0, 0. So what's it going to be over there? It's going to be 0, 0 as well. Okay? And if you remember, halfway right here is pi over 4. If I'm dealing with regular tangent, what should the y value be that matches up with pi over 4? What's the amplitude of regular tangent? If I'm just dealing with tangent, what's my amplitude? 1 is. So halfway in between here, what y value should I be at? I should be at the y value of 1. So that means over there, what ordered pair do I want? I want 1 and pi over 4. So we're going to do 1 and pi over 4, which is right there. And this is the opposite of it, so it should be over there. So now I just got to figure out what my curves look like. So this is kind of curved here. So if I take it and flip it, what does the curve need to look like over there? It needs to be flipped over. So it's going to be look like that, and that means the other one's going to be like that. So that's what inverse tangent looks like. So it's pretty much just taking this piece and putting it on its side, making it flat. So that's what inverse tangent looks like. All right, so now that we have all that, we're ready to evaluate some inverse trig stuff. All right, so y equals inverse tangent of, let's do the square root of 3 over 3. Y equals the inverse tangent of the square root of 3 over 3. So I should look for a match. Is there a match? Yes, where at? Pi over 6. So we get pi over 6 as my solution. Try another one. Y equals inverse tangent of 0.
Or would you have to refer to the graph?
I have to refer to the graph because there is no 0. So if I look at the graph, I go to the x value of 0. What y value matches the x value of 0? 0 does. So my answer is 0. And if I have to go to the graph on tangent, or on inverse tangent, there is only one answer I can get. 0 is the only answer I can get from the graph of inverse tangent. Why is that?
Oh, because they're asymptotes.
Because my other quadrantals are asymptotes. Okay, my quadrantals are negative pi over 2, 0, and pi over 2. And as Christian says, pi over 2 and negative pi over 2 are asymptotes. So those aren't going to be solutions. Okay, so if I have to go to the graph of inverse tangent, it's going to be to go to get a 0. Okay, all these other ones should be on your special language sheet. All right, so what about this one? Change that a little bit. All right, I want y equals arctangent of -1. Do I have a match for tangent in 1? Pi over 4. But I need to decide what to do with that negative. If I was dealing with inverse sine, I know to do what to my answer? Make it negative. If I was dealing with inverse cosine, I'd know to do what to my answer? Make the numerator 1 less than the bottom. So I need to figure out what I need to do. So what do I need to look at to figure out what I need to do? How did we figure it out with inverse sine and inverse cosine? What did we do? Not really quadrants. What did we look at yesterday? We looked at the graph. We went over there and found the x value of -1. If I go find the x value of -1, it's right there. And it matches this point right there. What is that point right there? It's a negative pi over 4. Okay? And if you notice, this graph is very similar to sine, because all of my negative x values are over here, and all my negative y values are down there, so that means everything has to be between there and there. So if I'm dealing with a negative and inverse tangent, what has to happen to my answer? It has to be negative. So inverse tangent is the same as, I handle it the same way as I do inverse sine. All right, very good. Okay, let's look at some compositions. I want cosine of inverse tangent of 1. Cosine of inverse tangent of 1. So I've got a function inside a function. Rachel? What do you mean, how about that?
Morally, how could you do that?
Yes.
Is it 1 over square root of 2?
Is the answer 1 over square root of 2? Yes. Share with everybody how you got that, AJ.
Because tangent of -1 is
The inverse tangent of 1
yes
is
pi over 4.
pi over 4. So that means this is pi over 4. And cosine of pi over 4 is
1 over square root of 2.
1 over the square root of 2, or square root of 2 over 2. Very good. That's exactly how it needs to be done. You do the inside piece first, and then you do the outside of the inside piece. Okay? Inside, you figure out what the inside is. So we figured out what this turned into this, and then I just need to evaluate this, which turns in.
Do you know what she
Pick which one you like. All right, sine of 2 times the inverse cosine of square root of 2 over 2. So what do I need to consider first?
The inside.
The inside, and more specifically, this part of it.
Okay.
Because what we're going to do is we're going to figure out the answer to this, and then what are we going to do with that? Multiply it by 2. So, what's my match for cosine and square 2 over 2? Pi over 4. So that's pi over 4, and 2 times pi over 4 makes what? Pi over 2. Okay, so now I'm interested in sine of pi over 2. Do I have a match for sine of pi over 2? No. Not on the special angle. So what do I need to do? Go to the graph. What graph do I want to go to? Sine graph. Which sine graph?
The regular.
Regular sine graph. Okay? And I don't know if that's the easiest thing to do. What else could I do instead of going to the regular sine graph? And I don't want to go to the inverse either. What type of angle is pi over 2? Quadrantals. What did we do last semester whenever I wanted a trig function of a quadrantal? I use what? I use the ordered pairs. That is correct. So we want to use the ordered pairs on the unit circle. So where is pi over 2?
1.
It's up top. And what's my ordered pair up top?
0, 1.
0, 1. Which one of those is sine? 1 is. So my answer is 1. So if you're dealing, say it again.
Why can't you use the inverse graph for that? It gave us
You have to think about it backwards. I'm just trying to think of the best way that everybody can handle it. If you can handle it a different way, then go with it.
No.
But if I try to show, there's about 3 or 4 different ways you can get the final answer. But if I try to show 3 or 4 different ways to everybody, they're going to go nuts. So I've got to pick one that I think works best and go with it. If you find something else, then go with it. All right. I want tangent of inverse tangent of pi over 4. Tangent of inverse tangent of pi over 4. So this part is equal to. No. I wrote down wrong.
Starting to say.
Oh, it is. That's bad. That's not what I wanted to write down.
Yeah, I was feeling really proud of myself.
Let's do that. Tangent of inverse tangent of 1. So the inside part is equal to pi over 4, and then what's tangent of pi over 4? 1. Does anybody notice anything there?
What's the side graph?
Yeah, the combination of those two cancels out. Now there is one thing you've got to make sure of. Okay, and that is, let's do the reverse of this. Let's do an inverse cosine of pi over 6. Okay? So, inverse cosine of pi over 6, what should our answer be? Our answer is pi over 6. Now, the one thing you have to make sure of whenever you've got an inverse cosine on the outside is you have to make sure your answer fits in the range. Okay? What is my range of inverse cosine?
0 to pi.
0 to pi. Okay? So when I'm doing this, I've got to make sure my answer is 0 to pi. So that means if I started with something like 7 pi over 6, is the answer to this going to be 7 pi over 6? No. Why? It's not in my range. Okay? So it is not undefined. I can still work it. So if this number right here is not in your range, then you've got to work it like if they're not, like you don't know that these cancel out. So if this isn't in the range of this, then you have to work it as if they don't cancel each other out. So what I mean is, let's find cosine of 7 pi over 6. Okay, I know I've got the pi over 6, so what's cosine of pi over 6? Square root of 3 over 2. Okay, what do I have to do with the 7 pi over 6? What else do I need to think about? It's 7. What is the 7 going to help me do?
Fine, but
Nope. Multiply, what is pi over 6 equal to? What angle?
Degrees.
In degrees? 30, and 30 times 7 is 210. What does 210 tell me about my angle?
It's in the.
It's in the third quadrant. What is my letter in the third quadrant? T, for tangent. So what does that mean cosine needs to be? Negative. So that has to be negative. Okay? Now I evaluate this. So what's my match for cosine and radical 3 over 2? Pi over 6. But what do I do with negatives and inverse cosine?
It's one less than
That's going to be one less. So my actual answer
It's fine.
is 5 pi over 6 because 5 pi over 6 is in my range, whereas 7 pi over 6 is not. Yes.
So if you have anything that's doing 8 pi over 7, 6 pi over 7?
Not necessarily. Depends on the problem. There is, you can get to a point where I could have been able to look at this and tell you that it's 5 pi over 6. But there's some other thought process that we're not going to spend time on. If you want to talk about that later, we can. But that it's not necessary because this problem doesn't show up very often. It's easier just to do this than to show you what it is you need to actually look for. All right, what about this one? I have cosine of inverse tangent of 1 minus inverse sine of 1. Cosine of inverse tangent of 1 minus inverse sine of 1.
So would you solve each like 2?
Yeah, and then just subtract it.
That is correct. You guys are on top of it. I need to get an answer for both of these and subtract it. So, inverse tangent of 1, what do I get? Pi over 4. Okay, inverse sine of 1. Inverse sine of 1 is that right? Let me go to the graph real quick. We go here to there, here, and there. So 1 would be pi over 2. That is correct. Okay. And then I need to subtract those two. Pi over 4 minus pi over 2. Negative pi over 4 is correct because we have to turn this into, I've got pi over 4 and I've got to turn that into 2 pi over 4, which gives me the negative pi over 4. Alright, so cosine of pi over 4. 1 over the square root of 2. Or the square root of 2 over 2. Now I need to handle that negative.
1 square root of 2.
No, that's how we will do it.
What? Right, that's, you're thinking about the inverse. Okay?
Is it okay?
Oh no, we need to figure it out. Somebody tell me what I need to do.
The numerator's got to be 1 less than the denominator.
We can look at the original graph. We can do that. Or what else can we do? We can think about the quadrant. What quadrant is negative pi over 4 in?
No, it's the third.
It's in the fourth quadrant. Because remember, if it's an angle's negative, I'm going down first.
Yeah.
So negative pi over 4 is in the fourth quadrant. What's the letter for quadrant 4? C is. So what does that mean these both are? They're both positive. So my answer is going to be that. As you see, there's a lot going on with these problems. Okay, and it's going to take time, so don't freak out right now. Okay, you're going to get used to them as you work this problem, and then or as you work this assignment, and then we'll do more work with them.
There's a million little rules for one little thing.
All right, so 288. I want 1 through 16. Well, 1 through 14 all. I want 16, and then I want 30 to 40 even.
I thought we had